So you can think of OpenFlow as a basis for implementing programmable networks, and through these programmable networks, you can implement techniques that support virtualization. So for example, going back to our VLAN case, where you have an environment where the user has control and can program network devices to support networking fabric virtualization. So recall that a VLAN, for example, can implement through tagging, you can select which ports a particular flow goes through. With OpenFlow, you can go beyond that simple functionality of a VLAN and implement much richer packet processing functions inside OpenFlow-enabled switches. So if this switch is under control now of a provider OpenFlow enabled, you can use the OpenFlow APIs to program a set of rules that will take place in each one of these devices when a packet is received on a particular port. So looking at a switch here, if it supports the OpenFlow protocol, you have a ports where network flows are coming in, and ports where network flows can go out. And within a device that supports OpenFlow, there is this notion of a pipeline with flow tables. And this is essentially a set of rules that can be used to apply to packets as they flow through the OpenFlow device. For example, you can change addresses, you can change ports, you can decide which port to send a particular packet based on layer 2 addresses or layer 3 addresses. And OpenFlow exposes through its standard protocol a mechanism to program these flow tables. And this programming is done by usually an external agent called an OpenFlow controller. So OpenFlow itself doesn't define what the controller does, which rules are in the flow table, but it defines the protocol by which the controller may be called when there's the device does not know what to do with a particular packet, there's nothing that matches in the flow table, and the packet is sent to the controller for processing. It also defines what the controller can do to add rules to this flow table, update rules, delete rules, etc. So basically the API that you see on the top here between the controller and the device through a secure channel is what OpenFlow enables. And that's a very flexible platform for implementing virtualization techniques. So basically, again, packets are intercepted. There's a high throughput data path if it's a hardware implementation of OpenFlow through these flow table pipelines. And packets that are not matched, akin to the privileged instructions that a virtual machine handles, these are handled by the OpenFlow controller. It's a slower path. It's not the hardware path. It goes through an external controller, but it can be used to program flow table entries for the next time a packet of a particular type appears in the device. It can be handled by the fast flow table pipeline. And finally, here's an example of an open source system for cloud computing that supports this Openstack Quantum, which is a service that enables the programmer or the administrator of a cloud to establish connectivity among virtual network interfaces managed by Openstack Infrastructure as a Service cloud computing software. So Quantum is a plugin that adds to the Openstack set of services and exposes a service that allows, for example, if you're a private cloud, if you have a private cloud, you can use this to configure multiple virtual networks in the same way that virtual private cluster in Amazon EC2 is done. But this again is an open source approach that can be deployed in a private cloud. And where it ties to OpenFlow is that the plugin that Openstack Quantum provides may use OpenFlow to program switches and implement the functionality of supporting virtual networks. So, putting things together, the picture that you may have within a cloud, this is an example of a private cloud that you could have. You have physical hosts that could be running virtual machines for multiple users. Let's say users here again color-coded. You have the red user, the yellow user, and the green user. And you have physical switches and you have physical hosts connected to this cloud. And you also have OpenFlow controllers. For example, the controller in blue could be a controller that has the ability to program the physical switches in the infrastructure as well as software switches that may run in the hypervisors like Xen or KVM, for example, in these physical hosts. So OpenStack services expose the ability for users to create virtual machines, and through Quantum you can also expose the ability to create and bind virtual networks. So what you can have is, again, a user coming in through this infrastructure and request not only to create multiple virtual machines, but also to put these virtual machines in a virtual network that will look like a VLAN. So OpenStack services are invoked. Nova is a service that OpenStack uses to create virtual machines, and Quantum is a service that's used to create virtual networks. And again, this service may use at the backend OpenFlow APIs to program the switches that software switches or hardware switches that will implement this abstraction of a virtual network. So these techniques apply well within a single administrative domain or connecting back to an enterprise network like we saw with Amazon Virtual Private Cloud. Or when you have a single domain, it could be multiple data centers connected by, for example, a dedicated link where you still have the ability to program the network devices connecting, to a large extent connecting these data centers. One problem with these systems is what happens when the virtual network has to span devices that cannot be programmed by a single controller. So if you don't have access to the devices connecting your virtual machines to program them using OpenFlow, for example, then approaches based on OpenFlow will not be able to control intermediate devices. So when you have virtual networks that span across multiple cloud providers, you have to worry about the fact that these may be under control of different administrative domains. You may not have the ability to control and program the infrastructure, and the approaches that we've seen here are difficult to deploy across multiple domains for these reasons. So that's the motivation for the next unit, where we begin to cover inter-cloud virtual networks towards a specific one that we're going to look in detail, which is the IPOP virtual network.